6, 5, 4, 3, 2, 1.
Alright, welcome back to Show Me Trucks. I'm gonna start a new series. Usually I restore old trucks like my 36 GMC over here. I wanted to make some simpler videos. The more you do this, the more you realize some guys kind of know some things and skip over others. My background, I used to work at a restoration shop, and then I also went to school for welding and machining. And before I moved back from California, I worked on wind turbines out there. One of our issues we ran into, people maybe not knowing how to drill and take out bolts, which is something you're going to deal with a ton on old trucks, or tapping holes. So I'm going to go through some information you should know and some tips that will make this way easier, because if you have worked on these trucks, you already know that a rusted, broken bolt can ruin an engine block. It can ruin cylinder heads all the time, but it can waste a whole day on one bolt. So I'll give you guys some tips on how to get them out and how to tap holes. The way I do it, I try to be a little safer because, like I said, you can rush things. Once you screw something up, some of this stuff you can't totally fix. So a lot of it you can. Why not just do it right the first time? I didn't know. People didn't know. I'll tell you guys one thing. On bolts, bolt is not named after the wrench that fits on the head of the bolt. Okay, you would never call this a 3/4 bolt. I can understand why some people would, because maybe the mechanic or tech or assistant that's helping them, that's their skill level. And trust me, I get it. This would actually be considered a 1/2-inch bolt because the diameter of the shaft that the threads are on are 1/2 inch. But if you were to measure this with a caliper, it's not going to be exactly 1/2 inch. It's going to be less, and we'll get into that a little bit later. Just as a heads up, if you're telling someone to get a 3/4 inch bolt and then they show up with this thing, you're going to lose your mind. This would be a 1/2 inch bolt. What size head it uses is not relevant. That's not what it's called. Other number is threads per inch. So how many peaks on the threads per 1 inch? You'll see coarse thread and fine thread. When we talk about taps, your taps will say on there, which is really hard because sometimes it's hard to read them, especially if they're older and they've been chewed up, or they always seem to rust on the numbers you need. Tap is a 5/8. NC is new cut, and we'll get into that a little bit later. But another thing for especially the car guys, you see this shaft without threads. If you have two surfaces that are going to be jamming on that, you want those surfaces on this flat shaft. If you have it on the threaded piece, like I said, this is smaller width than this shaft. But also, any force this way, say like a shock mount or anything like that, it will chew up all your threads. You'll see older bolts that have been on trucks a long time, and these threads won't even be there. They'll be beaten to death. Let's say you have a 1/2 inch bolt. This is the head of the bolt. This is the shaft that you're seeing right here. And then this is the threaded part at the bottom. Okay? So your shaft might be that full 1/2 inch. But once you get into the threads, basically the strength of your bolt is the bottom of your threads, the diameter. So that could be a 7/16, that could be quite a bit smaller. Any force that is running this way, obviously I would love it running on the strength of the bolt and not down here on the threads. Here's another amazing drawing for you guys. Another thing we dealt with out there is broken bolts. Turbines have big bolts. One thing you're gonna deal with on trucks is bolts that break off. The reason I want to show you this drawing is your threads, the bottom of your threads are always gonna be offset. Okay? They can never be straight in line or it wouldn't thread because these are offset. The bottom of all your threads is the weak link. Okay? Like if you're gonna break a board, well, if you saw it a little bit and then put pressure on it, it's almost always going to break in that sawn area. So the same with your bolts, okay? They're always gonna break at the bottom, and then almost always go and attach to the other weak link on the other side. If you're dealing with a flat surface, that's the hole. Your broken area is at an angle. So the problem we dealt with, and I'm sure a lot of truck guys, we've all dealt with it. Another spot you'll find it a lot is in LS engines and the cylinder heads. Okay, they have aluminum cylinder heads, the exhaust manifold bolts, because all the heat cycles, they tend to break off in there a lot. So a lot of times you'll get this where the bolt is broken off below the surface. It'll be at an angle. So if you try to drill a hole into the center of this bolt, problem that you have is a drill bit that looks like that is always going to try to wander. You know, you're spinning to the right or left depending on your bit, but it wants to catch and push it. Okay, that's why you always want to center punch your holes. And that was something that blew my mind, that people didn't really understand center punches either. So this is my favorite center punch. It has a spring in it, so you can kind of really get it centered, push, that spring pops a hole in it. You can also get a center punch like this, just hammer it. That gives your drill bit a hole to get started in. Once it finds its way, it's gonna stay fairly straight. But at first, if you don't, your drill bit is gonna wander. Well, one thing is apparently no one wanted to center punch holes. That drill bit, especially on an angle, it's gonna hit here and shoot it downhill, always. One thing you can do is if it is at an angle like that and you center punch it and it's still trying to push, like if that angle is pretty steep, you can start your drill bit at a little bit of an angle to keep it at a 90 degree to this flat surface. Once you get it started, you can straighten it out. But it needs, if it's pushing this way, it needs to get started enough so that it can't go that way. It's gonna start hitting. Always center punch your holes. That is my biggest tip, because what happens is if you don't and your drill bit starts to wander, well, if your drill bit starts digging into the base metal threads and starts knocking all these off, you basically ruined your piece. Let's say you knock all the tips of these threads off. That means you have this much contact surface, that little edge right here, instead of this much contact surface. I know that might not seem like the end of the world, but it is. It's a big deal. It's really hard to fix. Once you dig into this base metal, you're gonna need to either weld that hole up, drill, re-tap it, which is a pain, or you're gonna have to run like a thread cert, which is not the best. Just why not take your time, drill it right the first time. But that's something I wanted to show some of you guys about bolts and threads. Why do they break at an angle? Especially if they break just like a bone. If it's like a spiral fracture and it spins on its way down, you're gonna have the worst non-flat surface to drill and tap into. It sucks. Let's say you're working on a cylinder head. You broke off a bolt down in here. So basically you have no top to it. One thing that I did that really helped is if you have a MIG welder, you can just lay globs of weld in here until it gets above the surface. One thing that does is hopefully you got enough penetration so it's actually attached. Let it cool enough so that it's not really fragile. Well, all that heat will usually break up any pressure on these threads, but then you can attach some vice grips or pliers or something and spin that bolt out. Once a bolt breaks off in the threads, your tension should be gone. If there's a head on your bolt, it's clamping this surface and it's pulling all your threads upward. That means there's only pressure on the top of your threads. Once that tension's gone, this should be fairly loose in there. Another thing for you guys to understand is that your threads are never at 100%. They're never cut so that there's no room in there. They're always cut the gap in it. Sometimes that can be tighter. It's been a long time since I've been at school, but I think it's around 75 or 80%. There is an air gap in between there, but there's always a gap in there. So whenever the head breaks off and you lose tension in there, there should be a little bit of play. Yeah, there's not always, and sometimes, you know, bolts break off and they kind of mushroom at the top or have issues. But if you are having a bolt broke off in the threads, hopefully you can weld on it and unthread it. Also, what you can do, especially in the case of what we were dealing with, is it is a big bolt. You can drill into the center of that bolt. Sometimes the drill bit will catch and just unthread it, because like I said, there should be no tension on there. And if it can come out the bottom, great. If it can't, there's left-handed drill bits, and hopefully that drill bit snags in there and unthreads it back out. Or if you want to, you can drill in with a small bit and use a easy out. It screws in, it's tapered, hopefully it snags, and then unthreads that out. They're not the best. Trust me, they're not. Sometimes they don't want to catch. Sometimes if it's too small or there's way too much tension on it, it'll snap off, harden, just like a tap is. Usually the harder the metal, the more brittle. I will recommend that I always do the smallest drill bit and the smallest easy out to start, because if it starts getting chewed up, you can always step up. But if you go straight to the biggest easy out, you'll have problems. Also, if you use the easy out that is the whole width of the bottom of your threads, like I said, you'll start chewing into your base metal. You can have more issues. Usually what it is yeah, your drill bit will come off center and you'll start chewing in. Basically, once you get out of your bolt, you've screwed yourself. What it will start doing is it starts to kind of start mashing all your threads together, and then there's tension. There's no way you can really get that out easy anymore. So if you drill out of your main bolt, you've caused so much more issues. That's why you should always take it slow. You are rushing things, you almost always screw it up. That's just how it is. It's insanely frustrating when a bolt is stuck. Go slow. That's the best way to prevent a huge headache, because welding holes up and then re-drilling and tapping it is not fun. Also, you got to understand your material. You're going to deal with it a ton. That's the reason I can even talk to you. I've dealt with it so many times on these old trucks, especially the Pennsylvania and Missouri trucks. The California trucks are amazing, and a lot of the bolts come out. Talk about tapping bolts. I'll have some video of me tapping the bolt for the boxes on my 36. Let me explain different taps to you first. This is the tap that I used for, so this is a 1/4 20, so a 1/4 inch width and 20 threads per inch. If you pay attention to a tap, those little channels are called flutes. The flute is to get the metal chips out of there. So the same with the drill bit. These flutes, whenever you drill, metal shavings come off. Well, they're stuck in that hole and they need a way out. So let's say you're drilling with this little drill bit that doesn't have a whole lot of length in the flutes. Once you get below flutes and keep drilling, those chips have nowhere to go, so they're putting pressure on the outside and it gets stuck in there like a suction. So be careful whenever you do that. All those chips need somewhere to go. Well, that's the same with when you're tapping. When you're tapping, you already have a hole in the metal, and whenever you tap, it is not making your hole wider. That's why you need to always make sure you use a tap chart, look it up on the internet. That way you have the right drill bit. Your drill bit is going to be barely bigger than the width of the bottom of your pitches, because if they're not, this tap is going to get bound and stuck in there. So it needs to be a little bit wider, and that gives you your, like I said, it's a percentage. Your drill bit is going to make from the bottom of the black peak to the bottom of the black peak, and then your tap is just, it's cutting out the tops of the peaks. Nothing too crazy here, but if you use the wrong drill bit, too big will give you a lot smaller peaks, and then your bolt doesn't have as much to hang on to. If you do that, a lot of times whenever you run your bolt in, it's gonna strip out. It's gonna knock the peaks off of that bolt. It's just not gonna have enough to grab onto. Too small is just gonna give you issues whenever you go to tap it. Your tap's gonna get stuck. If you look at these taps, especially this 1/4-20, it's a new cut tap, or where you're tapping a new hole. It's very tapered because it needs to cut a small amount, and then as you get deeper in there, it cuts more and more until you're at your final thread width. This tap would be a bottoming tap. Let's say you have a hole and you need to tap it so that your bolt goes all the way to the bottom. You'd use a tap like this. You can also, there's also like chaser taps, which just clean out threads that are already there, which is something you'll do a lot with cars, especially in engine blocks and things like that. I almost always just use a new cut, just because I'm almost always just making new holes. One thing you'll notice when you're tapping is make sure and thread in a little bit and then thread out. So what happens is your chips all get built up in there, and then it binds up your tap. Again, just like the bolt, your tap is not the strongest, okay? It's not as strong as you would think, you know, a 1/2 inch wide tap is. Your flutes are dug down so deep, that's how strong your tap is, okay? And they're hardened, which makes them more brittle, and they're trying to cut a bunch of metal, especially the deeper it is. Let's say you're going into a cylinder and you're trying to cut, you know, all of this length at the same time. It's just a lot of torque on it, and you'll break taps off. And if you want to know how frustrating breaking a tap off is, it's unreal. And especially if it's in a part where it's really hard to get out, because now it's just a bunch of brittle metal in there that you're trying to extract, and you're gonna mess things up. And go slow. I always recommend, do not run a tap in a drill and just try to jam it in there. So basically what you're doing with the new cut is you need this tap to be as straight as possible. You need your hole that you drilled ahead of time to be as straight as possible. If you have a really oval hole and you're trying to tap it, the peaks on one side of your hole are gonna be really short. It's just not good. Don't do that. Whenever you're starting to tap a hole, I put a good amount of pressure on the tap so that whenever it digs in, it moves down. If you just stay in one spot and ran your tap and didn't go farther into the metal, it just breaks off all your threads that you're making into the base metal. You'll see in my video, I'll run oil on taps whenever I'm running it in steel. If I'm running aluminum, I do not run oil on my taps. Yeah, it wears your taps out quicker, but that oil just clogs up your tap, and the soft aluminum really stays in there. Always check the end of your tip. A lot of times on the very end it'll either break the edges off or it'll get stuck in there, and that metal, especially in aluminum, can be strong enough that it makes your hole a little bit bigger than you wanted. I like to chamfer the top of all my holes if I'm gonna thread them, just because sometimes whenever you tap, it kind of mushrooms the top, and I don't want any damage on the top of my threaded hole to make it so that my bolt that goes in doesn't thread in smoothly. And then run that tap back and forth. Always run your tap in. Once you're getting bound up, always back out. You can always back out, clean all the chips and everything out of your hole and off your tap, and then run it back in. Another thing I will tell you, especially on these smaller taps, is if you see it's really starting to get hard to move your tap, and you see those flutes start twisting, back up, because like I said, you do not want to break one of these taps off. These little ones are fragile. You will break them off. You just will. So be careful, especially try not to go overkill on your tap handle. Drilling holes. I know this seems like the simplest, but this is something I see all the time. If you are drilling with a small drill bit compared to this large drill bit, you cannot run these at the same speed. You can, but you're gonna have a lot of issues. There's a equation in school, but I don't remember it anymore. But think of the outside of this circle is 1 foot versus that big drill bit, you're going 50 feet. Now, if you're gonna do 1 revolution in the same amount of time, obviously, you're going 50 times faster on the outside of this. Anytime you run a bigger drill bit, slow your drill down. When you run these really small ones, you can basically run your drill as fast as you can go. When you run these, don't go as fast as you can go. What you will do is you will heat up the metal, especially if you're using a dull drill bit. If you ever heard of heat treating metal, whenever it gets hot, it's hardened. So your drill bit always needs to be harder than your base metal. If your base metal, it gets heat treated and gets really hard, your drill bit is not as strong, especially if your drill bit is really hot, it starts weakening it. That's why you want to use oil, and that's why you want to run slow. I try not to ever get my drill bits too crazy hot. Try to run your drill at a slower pace. One thing you will find is if you're trying to jam this drill bit in there, a lot of times you get like the weirdest little tiny shavings or no shavings at all. That kind of is telling you either your drill bit's dull or you're running it way too quick. If you get like a real long string of chips coming off, that's usually kind of a good sign. It either means you have a really sharp drill bit, which is awesome, or sometimes that kind of means you're pushing really hard on your drill bit. Again, we've all done it, but try not to jam your drill in there as hard as you can because it dulls your bits really quick. Just like all your tools, sharp tools are the safest tools. Try to get new drill bits every once in a while, and trust me, I know it gets expensive. Different brands, I will tell you that the better set of drill bits you get, the more time it's going to save you, and time is money. Where I drilled holes for a whole day just on stupid stuff on my truck just because all my bits are dull. And then step up. Don't go from this is your center punch hole straight to this, 9/16 bolt. I always step them up a little bit. It seems to save my drill bits. Yeah, it takes a while, but unless you have the magical, most sharpest drill bit of all time, you can't ever just jump like that because this is not like a center. You don't start with these because there's not a good center in there, You kind of need that to be probably a 1/4 inch, or it can even get into the sharp cutting edges. Drilling holes gets frustrating, but like I said, it's always center punch. That way that drill bit doesn't try to wander around and then your hole's not even where you meant to get it. That will happen. Try to always stay perpendicular to the metal, stay at a nice 90-degree angle. But I will tell you, in machine shop, it's actually one of my friends, but if you ever go to welding in high school or machining, a lot of kids are just in there so they don't have to go to school. We're actually making this little air-powered wheel motor, and he was drilling out the cylinder sleeve, and he was having fun, and he just was jamming on the drill on the mill as hard as he could, and it just kept getting hotter and hotter. Obviously his drill bit is dull, his metal's hardening, you could tell it's just getting black all the way down it, smoke's billowing out. And then the teacher came in and had some kind words, and luckily we didn't burn the machine shop down, and I was on the other side, so I'm not taking blame for this. That's just an example of if you try to rush things, sometimes it makes it worse. Obviously, it ruined his part. He didn't care anyway. Try to drill your holes with the right drill bits, like I was talking about with the wind turbine. Some of the guys had tried to drill with dull drill bits, and they drilled so long into the hole that it hardened the already hard bolt. So no other drill bit. I mean, we went through packs and packs on one bolt. Once you screw yourself, a lot of times you just can't fix it. So hope you guys enjoy this. I know a lot of you guys already know some of these tips. All you younger guys, and that's the main people I actually started my channel for. I hope you guys learned some of this because the only way you guys learn is get advice from guys that have already dealt with it. We've already had all the headaches, and not even all of them. Trust me, I'm gonna learn a lot. I love talking to the older guys that have more knowledge than me. That's something you should always do. That's the best thing about swap meets and car shows and things like that is get information from these old guys. They might not be around forever. Any of you guys that know maybe that formula for the drill bit size and the speeds, or have any suggestions, you guys can always tell me what I'm telling you guys wrong. These are the things that I've been doing for a minute and I find are the best. So thanks for watching. Later.